This is your complete guide to Creality's new 32-bit mainboards that come in the Ender 3 V2 as a standalone upgrade and all Ender 3s from this point on. This video started as a patron request to make a BLtouch guide for the new Creality Ender 3 V2. But early on, it became clear that Creality's new 32-bit mainboard was turning up in many other places. I saw a live stream from TH3D where new standard Ender 3s were arriving with a new 32-bit mainboard, which can be confirmed on Creality's blog. There's a lot of confusion over the different boards, so I spoke to my contact at Creality to make sure I had all of my facts right. I want to make this video comprehensive yet concise. Everything is timestamped with links down below in the description, so let's get into it. Let's start by looking at what these boards are, how to get them, and comparing them to the old Creality 8-bit boards. The mainboard found in the original CR10, the Ender 3 and Ender 5 is known as a Creality Millsy, and it's an 8-bit board. There were a range of revisions, and in the later versions you could get a standard board with A4988 stepper motor drivers or the silent board with TMC 2208s in standalone mode. The difference in sound between these two is quite significant. In terms of volume, that's a huge upgrade, but there were still problems with both of these boards. Apart from them being 8-bit, which is quickly becoming obsolete, the 1284p microcontroller was always running out of room, so when you added a BLtouch, you had to disable other features. The board typically came without a bootloader, which means you needed to muck around burning one before you could easily update firmware via a USB cable. There was no physical ports left to plug in accessories, so for example when fitting a BLtouch you had to spend additional money on a pin 27 expansion board. Finally, the silent board is not compatible with linear advance, but more on that later. So on to the new boards, the 32-bit like the version 4.2.2 that came in my Ender 3 version 2. As we know, this board will now be coming on all new Ender 3s, but then there's also the version 4.2.7 on their store, which my research tells me people have been receiving even when they try to order the old 8-bit silent board. If you've got a new printer or you've ordered a new mainboard, you can tell it's a new 32-bit board by two indicators. Firstly, it will be version 4 point something, and secondly, it will have ARM written on the processor. So let's clear up the confusion for these new boards and the printers they come on. At the time of recording, the version 4.2.2 will be exclusive to the Ender series 3D printers, and the version 4.2.7 comes on the CR6, and it's also what you get if you order the upgraded silent board from their website. Now the 427 board is always silent with standalone TMC 2225s, but the 422 board comes in two variants, a standard version with HR4988 stepper motor drivers, they're the noisy ones, and then the silent version which has TMC 2208s in standalone mode. If we follow this logic, we can work out which printers come with which mainboards, but this is sure to expand in future as Creality adds it to more models. You'll remember before that I identified some problems with the old 8-bit Millsy boards. The good news is that these have largely been rectified. The new boards are 32-bit, they have larger flash space, so no more skimping to fit firmware features on. They come with a bootloader, they have additional ports for a BLtouch and filament runout sensor, so the only remaining problem is no linear advance for the silent boards. Again, more on this later. Let's look at how hard it is to fit this 32-bit board as an upgrade. Let's say you have an Ender 3 or 5 and you purchase the version 427 board. You'll be glad to know that physically it's plug and play. Reference this diagram as you're removing the connectors and then use this one as you plug them back into the new board. Both of these diagrams are linked below in the description. The next questions are where do you get firmware for these boards from, and can you compile Marlin yourself? If we come to creality.com/download, we'll see that under the Ender 3, and the Ender 3 V2, we can expand, and there's already 32-bit mainboard binaries. What there isn't, however, is the actual source code, which means if you want to customize anything or make any changes like additional mods, you're going to be completely stuck. Lower down the page, they also have downloads for the Ender 5, and this is repeated on their blog site, but the most accessible downloads are for BLtouch firmware, making it harder to get the firmware source for a standard machine. So I think it's better to compile the firmware yourself. The firmware that Creality uses is still Marlin, and it's based on this. By downloading straight from Marlin's GitHub, we're just ensuring that we have the most up-to-date firmware available. What we're going to do is to come to the GitHub for Marlin, and up in the top left we're going to select our branch. I recommend switching to the bug fix branch, as this should be the most up-to-date, and it's always been reliable for me in the past. We'll now click on the green code button and download the zip. Now we come and click on config, and we click to download the configuration bundle, which as we can see is matched to our bug fix branch. On the left we have the contents of the main Marlin download that I've extracted to a folder. If we come inside the Marlin folder, we'll see the configuration files, but they're just generic ones, and we need to tailor them for our specific printer. On the right hand side, I have the zip downloaded for the configurations. And by using these example configurations, our job becomes a lot easier. We're going to come inside config, examples, and then Creality. And then we're presented with a list of printers. What we're going to do for our correct printer is copy the files from inside one of these folders to overwrite the default ones from Marlin. Let's look at 3 examples. Let's say we have an original Ender 3 or Ender 3 Pro, and maybe it's got the new non-silent 4.2.2 board, or we've paid to upgrade to the silent 4.2.7 board. For that, we're going to come to Ender 3 Pro version 1.5, select everything there, and drag it to the left. When it asks if we want to replace the files, we're going to confirm that. The version 1.5 folder is missing the boot screen and status screen files, so grab those and copy them over from another Ender 3 folder. Scenario 2 is for an Ender 3 V2 that comes with the silent 4.2.2 board. For that one, you might have guessed that we come to the Ender 3 V2 folder, we select everything, copy it over to our Marlin folder, replacing the files when prompted. Final example, how about something like an Ender 5 that in the future might also come with the non-silent 4.2.2 board, or maybe for someone who's purchased the silent 4.2.7 board as an upgrade. For this one, we'll come to the folder for our Ender 5, and we'll stick with the standard Creality configuration, once again copying all of the files over and replacing when prompted. You can now open up the Marlin folder in VS Code and double check the following lines, making the changes if necessary. Firstly, in platform.io.ini, set your default environment to STM32F103 RET6 Creality, and this one is case sensitive. In configuration.h, set serial port to 1, uncomment, and set serial port 2 to 3. Just below that, you're going to have a choice of 2 options, depending if you have a 4.2.7 board or otherwise. For an Ender 3 V2, you're going to set your motherboard to board_Creality V4. Otherwise, if you have a 4.2.7 board, set motherboard to board_Creality V4.2.7. The 2 boards have slightly different pin mappings for the steppers, so setting the motherboard correctly will take care of this automatically. If you have an Ender 3 V2 with the new color LCD, this should already be in place, but it's worth scrolling down and making sure DWin Creality LCD is uncommented. If you're using a printer with a traditional LCD, scroll down and find Define CR10 stock display and add underneath Define RET6_12864_LCD. On the odd chance your processor says VET, write that instead. Optionally, you can also set a custom machine name. Here you can see I'm compiling for the Ender 3 version 2. Once this is done, come down to the lowest bar and click the tick for build. And hopefully after not very long, you'll have a success message that your firmware is compiled. or a 32-bit board, normally we come to .pio, build, and then the name of our target environment, and inside will be a file called firmware.bin. However, Creality uses a different bootloader that requires a unique file name every time we update the firmware. If we always used firmware.bin, it would only update the first time. So the Marlin devs have been very clever, and if we follow the same folder path, we'll find that our firmware binary file has a time and date stamp added to the end, so every time you compile the firmware this will be unique, and the printer should update from your file. So now that we've compiled our firmware, how do we actually update, and what about that color LCD on the V2? Sometimes people get confused if their firmware has updated, so before you start, take note of the version number in the display. The next thing you need is a micro SD card. Small capacity is preferable, and it needs to be formatted to FAT32. We then take our firmware file, making sure it's the latest one if we have more than one here, and it's the one that ends in .bin. We copy it over to the SD card, put the SD card into the printer while the printer is off, and then power up the machine. You'll notice the screen stays black for around 10 seconds, and then the usual menu will come up after that. I found to my dismay that the language had switched from English to Chinese, but I could verify that the version number was new and the update was successful. Fixing the language is easy. Go to the top right menu on the main screen and then down to the bottom and click, and you should be back to English. If you like, you can reinsert the SD card to your computer and delete the unneeded firmware binary. If you're running a traditional Marlin LCD, your firmware update is complete. However, the new screen on the Ender 3 V2 has a separate firmware update process, so let's cover how to do that. Again, Marlin has the exact instructions in a README on their GitHub. You might remember when we copied over the configuration for the Ender 3 V2, there was a folder called dwinset, and to update the color LCD, we drag this over to the SD card. We need to open up the back of the LCD, and we can start by removing it from its mounting flange. There are 4 bolts on the back that need to be undone, and then we unclip the back of the case to reveal the SD card slot where we insert our SD card with the dwinset folder. Don't forget to plug back in the ribbon cable. We now power on the machine. The screen will go from black to blue to orange, and when it reaches orange, the process is done. We can now turn off the printer and remove the SD card from the display before powering it back up, where we should find that the menu has returned as normal. Assuming it has, we can reassemble the case of the LCD, and now is a good time to test the menu functions and potentially start a print to verify your machine is working as it should be. If all is well, your firmware update is successful. So how do you add a BLtouch? The mounting shown in this video guide is for an Ender 3 V2, but the firmware and wiring is accurate for this main board in other printers. All we need for this is a BLtouch, extension cable, and a mount. What we don't need is a pin 27 board or programmer, so avoid any kits that have these. That means the only thing you need to buy is a BLtouch with extension cable. The one I fitted was 1.5 meters and that was perfect. 1 meter would be too short, so if you need to, get a 2 meter cable and just tie up the excess. For an Ender 3 V2, this mount is free and works really well. There's 2 versions and they're almost identical, but the less fillet version is going to stick a little bit nicer to your build plate. The standard version had some slight detachment for me, but was still usable. Step 1 is to attach the BLtouch to the printed mount using the hardware that comes with the BLtouch. We now use a hex key and wrench to loosen the upper left V-roller. We slide the BLtouch on its mount in from the left hand side until it's wedged tightly, do back up the V-roller bolt, and we're done. You can now attach the extension cable to the existing wiring going back to the main board, remembering to leave some slack so the cable is not pulling tight on the BLtouch. For a neater install, you can run the extension cable inside the braided sleeving, as I've done here for the last portion to the main board. Now to plug in our BLtouch to the main board, and one of the improvements of these new 32-bit boards is the addition of ports for things like BLtouch and Filament runout. This diagram is linked in the description and shows how I have wired my BLtouch I've plugged the brown, red and yellow into the left 3 pins of the BLtouch port, but I've plugged black and white into the Z- port where the Z end stop was previously connected. Depending on your extension cord, the connection could be a little bit loose, so you can use a dab of hot glue to hold it in place and ensure it's reliable. If you double check your colors, it should be pretty straightforward, so let's move on to firmware. With the wiring method I've shown, it's important to uncomment define Zmin probe uses Zmin end stop pin. This should be the default, which is why I prefer this wiring method. Next, we search for and uncomment define BLtouch, and then we input the offset of where our BLtouch is mounted. For the probe used in this video, that's -42, -10. Search for and uncomment define auto bed leveling by linear. The same for define Z safe homing, and in configuration ADV, search for and uncomment define baby step Z probe offset. We now compile and update the firmware with the SD card as we did earlier in the video, and if it's worked, you'll have a new level option on the main menu. We're going to come to Control, go to Restore Defaults, and then after that, come up and click on Store Settings. To test the probing, you'll first need to auto home, and at this point it's highly recommended to trigger the BLtouch probe with your hand, so that way if it's not working you can kill the power rather than have the print head crash into the bed. If all is well, auto home again normally, and then you can come to the menu option for level. Pressing this button is the equivalent of sending a G29 command, and with our basic firmware changes, this will probe a 3x3 grid and it will be quite slow. You'll also notice that the grid is oriented to the left hand side of the printer. If you want to up your grid to 4x4 or 5x5, increase the value from 3 for grid max points X. If you want your probing grid to be centered in the middle of the bed, in configuration advance, search for the word kinematic, uncomment the 4 probing margin lines, and enter custom values, which is how far from the edge that the probing grid will go. To speed up the probing, there are 2 settings in configuration.H. Increasing XY probe speed will speed up the horizontal movements between each probing point, and increasing homing feed rate Z will speed up the vertical probing movements. Here's an example of probing with a 3x3 grid, symmetrical probing positions, and sped up feed rate. You can speed up things even more than this, but keep in mind the faster you go, you're going to lose a slight amount of accuracy. To probe before every print, we need to add G29 after G28 in the Start G-code section of our slicer. This will probe the bed at the start of each print and automatically apply compensation. When you start your first print, you'll probably find the nozzle is printing in mid-air. To fix that, we need a one-time adjustment, which is setting the Z offset. We come to the Tune menu and scroll down until we reach Probe Z Offset. Turning the dial to the left will lower the nozzle, but the change won't take effect until you click, and then the nozzle will move down that distance. The aim is to trial and error until you have the perfect amount of first layer squish. With this mount, I found an offset of -2.26, pretty ideal, giving me nice first layers. If you're using a traditional LCD, the system works exactly the same, the only difference being that you need to store the setting yourself using the menu, whereas the V2 seems to do this automatically. BLtouch done, but how do we add a filament runout sensor? This one's easy because the new mainboard has a dedicated port. That makes it plug and play for one of these common 3-pin filament runout sensors, which are actually just a micro switch inside a plastic housing. We plug it in as shown in this diagram. In a terminal, you can send M119 and that will report whether the sensor is triggered or not and let you know if you need to swap the 2 outer wires. The firmware is pretty straightforward. We need to uncomment define filament runout sensor, and if we find our sensor is working in reverse, we can change the fill runout state from low to high. Also in configuration.H, we need to uncomment define nozzle park feature, and finally in configuration advanced, uncomment define advanced pause feature. There's a lot to customize here, but I've always been happy with the defaults. Again, we compile the firmware and update via the SD card, feed your filament through the filament runout sensor and start a print. Wait a little bit and then employ a ninja to snip your filament. This is detected instantly by the printer and it moves to the park position, but you'll notice nothing on the LCD. Normally, Marlin will guide you through the process, but with the Ender 3 V2, this doesn't happen. So I found I had to manually turn back on the hot end, wait for it to get up to temp, load in the filament, and then resume the print. Some filament will then purge in the corner before the print resumes. It would be better if the LCD gave some confirmation, but the results are good. I did 2 during this print and the change is quite subtle. So what does it mean that the drivers are connected in standalone mode, and what disadvantages does that bring? First things first, functionally, TMC 2208s are the same as 2225s, just with a different size package. Let's say we have an A4988 stepper motor driver, as found in the original Ender 3. It's possible to swap this out for a TMC 2208 without any further changes, and this is standalone mode. The beauty of this is no firmware changes are required and no wiring changes required on the board. And I imagine this is why Creality uses this method. It's also why in my firmware instructions, I haven't told you to change the stepper motor drivers in Marlin. Changing the wiring, in this case by attaching a jumper and plugging in the 2208, will allow it to connect in UART mode. And this is already done in boards like the Big Tree Tech SKR Mini E3 and the Easy Board Lite from TH3D. The downsides for the manufacturer is that firmware and wiring changes are required. But then the upsides of this UART communication are numerous, including driver diagnostics, G-code control of stepper current, various modes with a hybrid threshold between them, linear advanced compatibility, and sensorless homing. If we compare the TMC drivers in standalone mode, we miss out on all of these smart features. So that means if you need to adjust your stepper driver current, you're going to have to do so manually with a multimeter and screwdriver. My patron Glenn's Ender 3 V2 came with the VREF set too high from factory. The steppers got so hot that the extruder was melting the filament on its way through, requiring the VREF to be lowered, which is not really a convenient thing. The other thing that I've mentioned from the start is that this board is not compatible with linear advance. Say you compile your firmware, uncommenting linear advance and setting the K value, what you'll find is that the print starts like usual, but a minute or so in, you'll find the extruder stepper just stops turning. No errors or warnings, the printer will continue as if nothing was wrong. Overall, this board is a big improvement from the old one and a worthwhile upgrade, but it's worth noting that the SKR Mini E3 is cheaper, the TH3D Easy Board is higher quality, and both boards have a lot more functionality thanks to the stepper drivers connected in UART mode. Besides the step-by-step instructions in this video, I've also got some branches set up for this main board on my GitHub page. And for those who just want to click and download the firmware already compiled, I've got some free links to do that too. Now I have ordered a 4.2.7 board to verify everything in this video, and if there's any future updates, look for a pinned post down below in the description. Thank you so much for watching, and until next time, happy 3D printing. G'day, it's Michael again. If you like the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.